The other day I was watching TV, or the TV was on. I was doing something, I can't remember. But I was listening to a commercial. And it was on the news channel. So I thought it was kind of odd that this commercial was on the news channel, because it kind of centered commercials with the audience that, you know, and most people that watch the news have some kind of intelligence. But this commercial said, "Call now for your psychic reading." Can people tell the future? Can people see into the future? I got one question for those people that can see into the future. What's the lottery number, the winning lottery number for this week's drawing? It's all one question. Just give me 6 numbers. Why can't they give it to you? Because people cannot tell the future. Remember Chloe? Was it Chloe that got busted for fraud? She was on 9-100. I will tell you your future. Nobody can tell the future. Now, you might get struck by lightning and get hit by a bus and wake up and you can tell the future. I'm not saying that it's not possible to tell the future. What I'm saying is that a person being able to tell the future is it's impossible. There's too many things going on for you to be able to tell the future. All right? So what is probability? Probability is assigning. I don't know how to spell assigning. I don't know if it's 2 N's or not. That don't look right. A number value to a prediction based on past events, observations, or statistics. That's a Hubertism definition. You're not going to see it in the book. They give you some long, drawn-out definition that you don't understand. But basically, you are assigning a number to a prediction based on past events that you or somebody else have put in the record books, or observations, or statistics that either you or somebody else has collected. Let me give you an example. I probably gave you this example at the beginning of chapter 13. The little old lady on the highway, right? Did I give you that example? Yes or no? You're going down the highway. We've used Wild Hog Road, which is about 8 miles long. All right? And you finally get to the end of Wild Hog Road, and there's a little road, and there's a left-hand turn and a right-hand turn. All right? You get behind that little old lady, and she's going 30 miles an hour down a 55 zone for 8 miles. And it's about a solid yellow line the whole way, because you're not supposed to pass. And you got to get to, and she's the type of person that not only she has you behind you, she's got 5 or 6 others behind you. You got a long line of cars, because she's going 35 miles an hour in a 55 zone. And you get up to here, and this lane turns right, and this lane turns what? Left. Because it's a dead end. This way is to Anderson, And this way is the penalty. When you get about right here, what do you say to yourself? I'm gonna get in the other lane. No, you can't do that. You're fixing to go into the left-hand lane to turn left. You say to yourself, I bet you $1 she's going to get in the left-hand lane. And she does. How many times does that happen to you? All right. What you did is you made a prediction based on what? Past observations that you have had in the past. You always know that when you're late and you get behind the little blue-haired ladies club, and you come up to a stop sign and there's a left or a right, yeah, I can guarantee you each time that little old lady's going to go the same way you're going, based on past events. And that is what probability does. Probability uses the numbers 0 to 1. That's your numbers that you use. So in other words, everything is in terms of decimals. Everything is in terms of decimals. 0, the closer you are to 0, that's very what? Unlikely. I don't know if likely if you drop the E or not. I never have been a good one at dropping E's. Y'all have to look in your book. They give you a little scale from 0 to 1. See if you drop the E or not. I don't know. Halfway, okay, is 1/2 or 0.5. 0.5 is somewhat likely. Now, notice I put a 1/2 right there. Well, 90% of the time, a teacher, a statistics teacher, is going to tell you to speak in terms of decimals. And there are a lot of stat teachers out there that if you put it in a fraction or a percent, they'll have a conniption. So if you ever go into Math 120, if you have me, you don't have anything to worry about because I don't care. But there are some stat teachers that live, eat, and drink statistics, probability and statistics. And if you say, oh, that's a half probability, they'll have a cow. If you say that's a 50% chance or a 50% probability, they'll have a cow. So I'm just telling you. Some people say percent. Percent usually has to do with chance. Chance. Okay? Do not use the word percent in probability. Okay? How do you say probability? Well, it's a 0 probability, it's a 1 probability, or it's a 0.5 probability. That's how you're supposed to say it. But there are some that do care. Alright? Now, there's two types of probability. These are Hubertisms. There's the Mayberry probability. Which is the theoretical. I don't think I spelled that right either. Y'all got to learn how to spell theoretical. See, there's an H right there. Mayberry probability, or the theoretical probability, is based on numbers only. Okay? And then the physical probability, I don't know what they call it in there. Physical probability is based on what actually happens. Now, let me give you an example of a Mayberry probability. What is the probability of you rolling a 6 on a die? which is one die. 1 out of 6 chance. That's the Mayberry probability. But if you roll that die 10 times, and 3 times it comes up a 6, then that's 3 out of 10, which is 0.3. Well, 1 out of 6 is 0.16. Why doesn't the theoretical probability, which is 0.16, why doesn't it match the physical probability? It's supposed to match. Well, the reason is that's what the word chance is. In other words, you're betting that a number is going to land on a certain number, or a die is going to land on a certain number. Well, the chance of that happening is not this chance. It's this chance. Let me show you an example. You said that the probability, and how do you write probability? Well, you write like this. Probability, and you could put a 6, or you could say probability of rolling a 6. I don't care how you do it. On a die is equal to 1 out of what? 6, which is equal to 0.16. So you have a 16% chance of rolling a 6 on a die. But let's do the actual physical probability of rolling a 6 on a die. Everybody get your die out of your pocket. Everybody carries one, right? Yeah. So what we're going to do is we're going to go to dang old tools, dang old math tools, dang old technology. There's our die right there. Okay, so we're going to roll that die, and I want you to keep up with it. Well, I'll keep up with it too, because somebody will mess it up. I hit the output to a flip chart. There it is. Is that the flip chart right there? Let me move that. Okay, so I'm going to roll it 9 more times. I'm going to roll it 10 times. Ready? Another 4. I don't know why it doesn't put it in the chart. 1. Where'd it go? Where's my 3? Huh? Click what to the... Thank you. 3. Oops, sorry. Cancel. And roll. There's 5. Alright, so there's 5 times. I don't want anybody to say I'm loud anymore. That was what? Okay, so what's the probability of rolling a 6? The physical probability. I'll do the math for you. 0 out of 10 is what? 0. So why don't it match up? There's 2 different probabilities. The physical probability is hardly ever going to match up with the Mayberry probability unless you do it a large number of times. Look in your book somewhere and you should see something called the large number rule. I need you to, or law of large numbers, see if you can pull it up or see if you can find it. Somebody tell me what page it's on if you do find it. I'm still trying to log on. I'm going to try it again. Hey, dumb. Somebody knocked the crap out of this. I didn't do it.
It was me. I was not aggravated.
Oh, were you up here looking at porn? Okay.
My Wi-Fi's down at home.
Your what?
I said my Wi-Fi's down at home.
Oh, okay. I'm going to try it one more time. Y'all ever get this?
Yep.
Yeah, mine did that. I forgot, what's my username?
I don't know. What is your username?
Like, we were talking about the same one I used to CPC class.
Mm-hmm. I don't know why it's doing this, because I ain't never had a problem getting in.
Yeah, it happened to me today, too.
Oh well, not gonna worry about it. Y'all try to get on it through your phone and see if you can get in. All right, so what I asked y'all to do. Oh, did you find the law of large numbers? Okay, the law of large numbers basically says, or I don't know if they say law of large numbers or large number law, whatever.
Law of large numbers.
Thank you. Law of large numbers basically says that the more attempts you try, the closer the physical probability gets to the theoretical probability. Now, in about 4 or 5 editions ago in the Math 120 book, they had an article about a couple of students at a university that wrote a computer program that flipped a coin like infinite amount of times. They weighed the coin, they took detailed measurements of the coin. Did it come up?
I went through Blackboard, but I didn't go through.
Well, it doesn't matter. I tried that before. It should come up. But they weighed it. They put in the density, and they wrote a program on virtually flipping that coin. Let me try it one more time. No, that's the wrong password. Do me a favor. Log in yours and see if it comes up. I wonder if it's just holding back me because it's a... Let me let you do that if you don't mind. See if it'll come up with you. Okay, but anyway, they had this program. I'm sorry. Dork. There it is. Try it and see what happens when you come up. When you plug into it. Yeah. I think there's something wrong with our MyLab Plus. Yeah, there's something wrong. There's something wrong with our end. I'm not going to worry about it. Thank you. But anyway, they wrote a program and they typed in 100 times and they flipped it and got a probability. They typed it, they said 200 times, 300 times. Does anybody want to take a guess at how many times they flipped that coin virtually to get to 0.5? Because what's the probability of heads on a coin? 0.5. Why? Because there's one side, there's two sides, and there's one head, so 1/2 or tail, 0.5. You know how many times it took them to virtually flip that same coin? It took them close to 10,000 times. And the probability was 0.495. Now, why do I bring this up? Well, in the last chapter, we talked about statistics and getting information. Let me ask you a question. If you're a director of a division, let's say you're the head of the nursing floor, let's say you've been a nurse for 20 years, and you're the head of the third floor, which is blah, 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 blah. And you got to give all the floors have to give a presentation on blah, 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 blah. Okay, with what you do for a living. Or if you're working at Michelin, or you're working at Bosch, and you've been there for 5 or 6 or 10 years, and you are a supervisor, and you're supposed to go in to a supervisor's meeting and present your department or your floor or whatever the case may be. Are you going to go in there with a couple of years of information? Are you going to go in there with at least 10 or 15 years of information? Huh? You're going to go in there with 10 or 15. Because what is the high-ups going to ask you? They're going to ask you, how can we do it what? Better? How can we do it what? More efficient. And if you walk in there with 2 years or 2 weeks of information, you might get fired. Or you're going to get made fun of. Because 2 years or 2 weeks information is not enough information to give to a supervisor. You need to go in there loaded for what? Business. Y'all don't know the expression, loaded for? Y'all's parents really failed you.
Yeah.
Loaded for blank. Bear. Loaded for bear. Y'all have no idea what I'm talking about, do you? Y'all suck. Here we go. Back to Google. So y'all won't know I'm crazy. Loaded for bear. There it is right there. Loaded for bear. What does it mean? An allusion, basically an idiom, a saying. To equip oneself with the sort of heavy weaponry suitable for hunting large game. In other words, when you walk into that meeting, you want to be ready for anything. And you're not going to walk in there ready for anything, preparing, oh, I got a meeting in 15 minutes. Okay, I need to go pull this week and last week. You're going to be embarrassed, if not fired. And that's what the big number rule means. If you want to get the best outcome, then you need to think about your data. You need to think about how far to go back. You need to think about how many people to survey. You don't want to go into a director's meeting and you survey 5 people out of 6,000. That's not going to be good either. So, make sure you remember the large number rule. What is probability? Probability is the number of desired over the number of tried. Desire is what you want, like heads, or tails, or a 6, or a 2 on the die. The number of times you roll it is the number of times you tried. So a while ago, the probability of rolling a 6, the physical probability, it was 0 out of what? Which is 0. The theoretical probability was 1 out of 6, which is equal to 0.16. This is the number of times you got 6. This is the number of times you tried. This is the number of times there was a 6. This is the number of possibilities. It's still the same thing. This is the number. This is the possibilities. This is the actual number rolled. This is the number of times you rolled. Physical probability, theoretical probability. It's the same thing. Numbers are not going to come out to be the same. And that is the interest within somebody that is interested in probability and statistics. You may know somebody that likes to gamble. You think they like to gamble because they like to make money? Maybe. But sometimes they're intrigued by the probability. I know, wish I could think of his name right now. Hold on, it'll come to me. It started with a B. He was a professor at Clemson, and he wrote a paper slash, he wrote a big old book, not a book, but Jeff Brawley, Dr. Brawley. I'm going to show him to you. A little short man. He died a while back, about 10 years ago. He was my, I can't remember what he taught me in. I don't even know if he's on Google or not. But he was intrigued. He was a math professor, and he was intrigued by probability. I want to say Brawley. His name was Joe Brawley, I think. Let me look up Joseph Brawley. Ain't that Joe? Joseph Brawley. B-R-A-W. Joseph Brawley and gambling. How do you spell gambling? Is that gambling? Well, anyway, I guess you have to look it up. But anyway, wait a minute. Let me just look up Clemson. Might have been somebody else. Joel Brawley. It was Joel Brawley. That was it. Yeah, that's it. And he basically wrote a big. He won a math award. That's it for the probability, and talked about. He talked about if you're going to gamble, is it smart to gamble a little bit at a time, or is it smart to gamble just one big sum? And he went through the mathematics of it. Let me see if I can find it. Gambling. This is it, probably right here. Well, anyway, you have to look for it. He came and presented at Tri-County Tech shortly after I started working at Tri-County Tech, and he had this big old, and people were just filled up Oconee Auditorium, and it was filling out into the hallway. And he wrote about, there it is. It's he basically proved that it's better to take $1,000 and bet it than it is to take a 10 here and a 10 here and a 10 here, because the probability of one thing happening is a whole lot higher than the probability of this happening and this happening and this happening and this happening. Is basically what he was saying. And you just have to read it, but it's on there somewhere. I'm sorry. Let's see if he's got any pictures of him. Yep, there he is. That's him. One picture. I think he'd be more famous than that. There's more pictures of me on the internet than him. That's the only picture on there. He was a nice guy. Very, not eccentric, but very interesting. Okay, I'll shut up. Let's see, where were we? All right, so let's talk about how to do probability. Well, see, one thing about probability is you got to know what you're actually dealing with. If I asked you the probability of pulling a face card out of a deck of cards, people would go, okay, that's so-and-so, so-and-so over so-and-so. Some people would go, I don't know how many cards are in a deck of cards. Some people would say, you pull something, what's the probability of rolling a 7 on a die? Some people would say 1/6. Well, it's actually what? 0. Good job. Because it's not a 7 on a die. All right? So you have to be able to read. You have to be able to extract information from what you read. And you have to be able to make sense of what you're dealing with. I use a deck of cards because every once in a while I'll teach a class and there'll be somebody in the class that don't know how many cards are in a deck of cards. So, that's one thing I always use. There's 54 playing cards in a deck of cards. Usually, the big joker and little joker are not used unless specified in games or can be used in games. Most of the time, there is 52 playing cards in a deck of cards. All right? Each deck of cards is divided into 4 what? Suits. Hearts, diamonds, clubs, or puppy's feet, depending on what you call them, and what? Spades. Now, that's 4 suits. Each suit has 13 cards. Ace, which can be used as 1 or 11. A 2. A 3. A 4. A 5. A 6. A 7. An 8. A 9, a 10, a jack, I'm going to put a 10 right there, a jack, a queen, and a what? And I'm just going to okay, so each one of these suits has these 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If you ever forget, you can do the Soldier's Bible. You ever Google the Soldier's Bible? Y'all don't Google anything, I don't think. Soldier's Bible. I'll tell you all about dang old Soldier's Bible, dang old deck of cards. Well, where is it? No, that's not what I wanted. Let me put Soldier's Bible, deck of cards. Dang old. There we go. And there it is. And this story's been around for 100 years. But there it is. You see, the ace reminds me of God. And blah, blah, blah. Now, I'm not trying to convert anybody. Okay? So I don't need the ACLU being called. This is just a way that you can remember how many cards and all that good stuff. All right? I always, when I first saw it, first I heard it was a song by Bill Anderson. The Whisper, Bill Anderson, Whispering Bill Anderson. Anyway, he used to own Po Folks. You ever remember Po Folks, the restaurant? Well, he owned that franchise. He used to be a country singer, but he was one of those country singers back in the day, and he just sang like this. He was real quiet, and everybody called him Whispering Bill. Anyway, he sang a song, and it went like this, blah, blah, blah. How many weeks are there in a year? And how many cards are there in deck of cards? How many suits are there? There's 4 suits. How many quarters are there in a year? 4. And it goes along with all that. So that's something you learn every day, which I want you to learn more things in math in here. And so far you know what loaded for bear is and a deck of cards. So you're learning something. But what if I was to ask you, what is the probability of pulling an even card with ace being a 1 or an 11? Well, you have to know what the cards are worth. Well, each one is face value. So let's take out the ace. I feel like quitting sometimes. Take out the ace. Take out the 3, the 5, the 7, the 9. What about these guys? Well, if the 10 is even, that's okay. These are considered what? Face cards, which are 10s. Okay? So these are okay. So, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 cards that are even. But in the whole deck, it's 8 times what? 4, which is... So your probability of picking an even card out of a deck of cards is 32 over what? And somebody do that. What do you get? What's 32 divided by 52? .61. Now, let me ask you a question. If you went to Las Vegas and you found a table that said, pick an even card, would you win a lot of money? No, you would not win a lot of money. You would win a little bit of money. Why? Because the probability is high. Is last time I checked, is the bank and Las Vegas in the welfare business? No. What does the bank in Las Vegas want to do with your money? Do they want to give it to you, or do they want it? They want it. Do you think that Vegas is going to pay you $1,000 on the dollar with a 61% chance of winning? No. Vegas is going to pay you high odds on low what? Probability. So let's change that. How about the probability of picking a king in a deck of cards? All right, somebody give me that probability. I'm sorry? Now, if you go to this table and it says pick a king, that's all it says. And there's a guy standing there and it says pick a king. Will you win a lot of money here? Yes. You may lose a lot of money also. But if you hit a king, you put $100 down and you hit a king, you're doing pretty good. Let's figure that. And that goes into the probability for and the probability against. Oh, the odds. I'm sorry, odds. Odds in favor is the probability of success over the probability of failure. Odds against, and that's what they use. That's what they use in is the probability of failure over the probability of success. And when you do odds, you always want to leave as a fraction, and you'll see why in a minute. All right, now if I picked a king, would that be success or failure? That'd be success. So somebody tell me what the failure would be. This is probability of success. What is the probability of not picking a king in a deck of cards? 48 over what? 52. This is called, big word, what's that word? Compliment. And that's not like your hair is pretty. Not that kind of compliment. It's what makes up the whole. What makes up a whole deck of cards? 52. If 4 are being used, what's the complement? 48. If 10 are being used, what's the complement? 42. If 20 is being used, what's the complement? 32. Okay, remember that. Complement makes up the whole. So now we're going to figure the odds against. Odds against picking a king. Is the probability of failure over the probability of success. 48 over 52 divided by 4 over 52. Multiply by the what? When you divide by a fraction, you multiply by the and what do you get? 48 to 4 odds. So if you place a $100 bet that you're going to pick a king, and you pick a king, what you going to win? Dang old $1,200. How'd I get $1,200? Well, somebody take 48 divided by 4. 12. 12 times 100 is what? That'd be a good payoff, wouldn't it? I'd want more. I'd want more than that. Question. And what do they mean 50 to 1 odds against winning? Well, let's do that. Oh, and you need to know this right here. You need to take your big highlighter, especially this one, because that's the one that's used with gambling. Odds against. Let's say that you bet on a horse. Betting on horses. And you have no idea how to bet on horses. You don't know nothing about horses. You don't know, but you like their names. Okay? And let's say that there's a list of horses, and you like Shucker's Joy. You just like that name. Shucker's Joy. And you like that name. And he races tomorrow at 10 o'clock. But his odds against winning are 75 to what? 1. So you say, you know, I ain't got nothing to lose. I'm broke. I found this $100 bill on the side of the road the other day. I'm going to bet on Shucker's Joy. I'm going to bet $100. What you going to win? Well, 75 to 1. What's 75 times 100? You're going to win $7,500. But there's only one thing that has to happen. Shucker Joy, who is crappy, is going to have to win. Can that happen? Yes, it can happen. It has happened. Huh? Or, well, you didn't, you're not out $100 because you found it on the side of the road. Well, a lot of people wouldn't. All right, so you feel good about that? You feel good about probability? I was going to try to pull up a question, but if I can't, we're not going to go on because I'd like to see what's next in the book. Try it one more time. I don't understand what's up. Say again? Yeah, but you're getting on it with your phone. It don't make any sense. Oh well. I don't know what's wrong with it. Somebody tell me what the next chapter says. What is 6.1 or whatever chapter we on? I don't know. 12? What does 12.2 say?
Theoretical probability.
Okay, we already talked about that. 12.3.
Odd.
Alright, we already talked about that. What else?
That's
Is that all we go to?
yeah.
Okay. Well, let's do one out of the homework. Get 12.3 homework. Let me see it. If you don't mind. That's odds.
Mm-hmm.
I feel better doing this with where I can see better. Well, that gives, okay, there's a roulette table, number 60. Well, I'll tell you what. Y'all got 3 sections of homework to work on. Let's do that. Let's let y'all work on that for a little bit, and then we got plenty of time. So, set attendance for today. Today's Monday, the what?